Hello and welcome to Video Notes 1.6, where we're going to be talking about describing associations and correlation. We're going to do a bit of a pivot, a turn here, where instead of looking solely at just one variable at a time, we are now going to sort of look at two variables simultaneously, comparing them, seeing if there's some relationship or association between them, and whether we can analyze it, explain it, make sense of it at all. So the new vocab coming around: scatterplot and association. We got form, outliers, direction, and strength. We've got different variables: explanatory and response variables, and then of course correlation coefficient, R value. And we are going to, in this video, learn about how to make a scatter plot on your calculator and how you can find the R value, the correlation coefficient, on your calculator. So we're going to start out with making a scatter plot. So a scatter plot is a display that shows the relationship between two quantitative variables measured for the same subjects. Really important that we're talking about, the same subjects and grabbing two different variables about that subject. So for example here, what we have is the study time in hours for some students and the test score in percent for that same student. And so we're going to make a scatter plot by hand. The first step is always to try to figure out what is your scaling going to be like. Something that's important is that your scale does not need to start at 0 when you go to do this. You can start halfway through your numbers in order to focus in on it. For example, if we were to start at 0 for test scores along our y-axis, we would have a lot of blank space, and we might see different sort of relationships than actually exist there. So it's okay if you sort of start things differerly. What I'm noticing is that, though, my study time is relatively low in score, so I can go ahead and actually just label, by ones, or even I think I could do scale by half hours. But with the test scores, what I'm sort of noticing is, I don't want to start down at 0. I want to sort of start maybe midway through the 0 to 100 range that percentages usually are. And an easy way to sort of figure it out is you can do some math to kind of figure out what is the range I need to cover in total. Like my maximum here, it looks like it is a 95. And the minimum score looks like it's at about a 45. So that's a distance of 50. So I need to make sure I'm, scaling at least 50 along the y-axis in range there to make sure things work out. And so what I think ends up working out really nicely is if I sort of scale by 2.5s, you can count out the number of things to make sure it works. So I'm going to scale, okay? You can pause and scale accordingly if you want to, or just follow along and try to catch up. So here I am, I've scaled it now, so that way I'm guaranteed to get all the data in there, and there's not going to be a ton of blank space, so I'm filling up the whole graph. And then now I'm going to go ahead and plot my points over here. So I think you probably know how to do that, but just a quick recap. So if we look at, for example, this very first sort of ordered pair, 3 and 85 is our pair. So at the study time of 3, I'm going to trickle on up to 85, which I believe is here, and plot that point there. And then I'm going to lather, rinse, repeat for the rest of them. Again, you can pause and do it all and see what I come up with, or just try to catch up. So you can see that all of my data points are now plotted there for us. But let's see how we can do this on the calculator, because you're usually not going to make scatter plots too much by hand. So let's see how we can use our calculator to make a scatter plot instead of doing it by hand. The first thing you're going to want to do is go to your lists here and enter in the data. You have to make sure as you're entering it that the pairs, the things that are paired together, remain paired together here. So I have 3 with 85 because the first data point is 385. You can't just throw them in willy-nilly. You will not get the scatter plot you expect to see. After you have your data in there, then what you're going to do is you're going to go to your stat plots, so seconds, and then hit the y equals button. And we're going to go ahead and just go to this first plot. It's already turned on for me. If it's not on, make sure you turn it on, and probably turn off anything else. You can sort of see what's on and off by looking up ahead there. And we're going to choose this very first one. This is the scatter plot. When you hit it, you will see that it kind of opens up a new thing for you here where there's an X list and a Y list. So I placed all of the number of hours studied on my X list. So I'm going to go ahead and leave that as L1. My Y list is my L2. So I'm going to change that second 2. You can change sort of what the dots look like. I like using the squares. They're great. You can change the color if you want. But after you do all of this, you're going to go ahead and hit zoom 9, and you'll see that you have your scatter plot there. And I can check it up against what I drew on the actual paper and see that it works. Before we move back over to the notes, just wanted to show you one thing. This has happened to a couple students already in class, which is they get an error message. And the reason they're getting an error message is they're trying to plot something statistically where it's just impossible. Sometimes it's because literally they're like saying list 3 and list 3 is completely empty. But another way it can pop up is if you in fact have a mismatch in the number of values in your lists and you're trying to use a scatter plot. So let me show you. So going back to my lists, I'm going to come in and I'm just going to delete the first one. Let's say I was typing in quickly, I ended up missing a number, and I didn't notice that my lists are different sizes here now, which can happen with longer lists. So now when I go over to my stat plot here and go like, oh, I want to turn that on, go ahead and hit zoom 9, you'll get this error, mismatch dimension. That means that you're having an issue with this idea of like, oh, I'm trying to graph a scatter plot, except for one of my lists is a length of like 12 and the other one is a length of 13. So if you see this on a test, that means go back in and confirm that you've entered all of your data correctly. So whether you're making the scatter plot on your calculator or by hand, or whether it's just given to you, a very common sort of follow-up question is to describe the association that you see. And so we had CSOCs to help us sort of remember what little elements to think about for univariate data, just one variable. For scatter plots, we have CFODs. And so that stands for context, form, outliers, direction, and strength. So just like with our sort of histograms and dot plots, when we're describing, we want to make sure we're using the context of everything. So the easiest way to do that is to state it right away. That's what I do. So here is the start of my description. The association between, and then I state the two variables. So up above, I can see that we're comparing study time and test scores. So I would write between study time and test scores. And we're going to ... ellipse that there because we are going to have some adjectives to toss down on this here. So let's go ahead and see the different things we should be mentioning. The first one is the form. The form of your data there, it sort of describes kind of like the same thing as like shape earlier. What do you see there? And we only have 2 buckets we sort of think about this in. We'll say that if it looks roughly linear, seems like the data is following a linear pattern, we would say then it is linear. And if we say that something doesn't look like it's linear, we would just say nonlinear. So you can see a couple of examples here. So over here we have sort of this data here kind of following overall this straight line, not perfectly straight, okay? Has a little bit of variability there, but also like not looking very curvy. On the other hand, we can see over on this other example that the data doesn't really follow a straight line. It kind of curves on down that way. So let's look back up at our scatter plot and decide, are we looking at something that seems to be linear or nonlinear? So what do you think? Personally, when I'm looking at this, I definitely am seeing something that's a little more curvy. It kind of seems like it's kind of going something like this. But it can be a bit subjective. So if you were like, oh, linear, you might have been sort of kind of cutting through the points in a different way than I was. And we'll eventually figure out whether or not that's a good call or not. But for now, we're just kind of using our eyeballs. So I am going to say that this is nonlinear. And I'll add that to my description in a moment. The next step of our description is outliers. And so outliers, I think, I don't really need to define too much here. I will say, though, that we are not going to be learning any specific rule like we did for univariate stats about whether something is an outlier or not. We're just going to kind of eyeball it. And sometimes we'll even toss down sort of maybe the word like an apparent outlier just to maybe cover our butts. So we can see that in the examples given, this point right there is an outlier for sure. Given that the rest of the data is a perfectly straight line, I would say that's an outlier. And then here, we can see sort of this curviness to it, and so it seems like maybe there's a couple of outliers here in this particular case. So what about our scatter plot? And so this is really dependent upon sort of what you're seeing. So that's why I like drawing in sort of my trend line first, because then it helps me decide, okay, now do I see points that are like vastly different than what I was sort of seeing as the trend line? And in my case, yeah, I feel like I'm seeing this right here as an outlier. So I'm going to go ahead and say that there is one outlier here in my scatter plot of data based off of my trend line. All right, so we got the FO of FODs. Let's keep going. Direction. So direction also kind of falls into two buckets. Either you're staring at something we call positive direction, which means overall the data is increasing. Both variables are sort of overall increasing with each other. So we can see in here in this example here that overall, as we move to the right, the points are moving up. It is not a perfect one-to-one sort of scenario, but for the overall on average. And then same thing, negative direction would be when we're sort of seeing an overall decreasing relationship. So as one variable increases, the other will be decreasing. So from my perspective up here, I am seeing that study time as it increases, overall test scores are increasing as well. It is, again, not perfect. As we note, there's an outlier where it's like, wait, you studied more than some people and got a worse score. What's up with that? But overall, we're seeing a positive relationship. Finally, strength. Strength is talking about sort of how close things are to this sort of trend line. Like I said, I like to draw on the trend line to start out with because it helps first off with like solidifying my form, and then it helps me know and understand whether I have outliers, and then this last part here about like how strong is it? Is it really strong? Is it sort of strong? Is it kind of weak? Is it really weak? There's a lot of different sort of buckets to fill it into. For the time being, let's just kind of call it two things. It's either weak or it's strong. And then if we start finding some things that are kind of in between, we can decide. So like this example here, like I see sort of this trend line kind of going through it, and the points are kind of far from that trend line. So I would say that this is on the weaker side here. On the other hand, here I'm seeing this trend line that is more curvy, and those points are very close to it. So I would call it a stronger relationship. So what about ours? Well, this is tough because there's very little data points. More data points kind of help you solidify this a bit. When you only have 10 data points, it makes it a bit tougher to make a judgment call. I'm going to say, based off of sort of things here, I've got this outlier that, is kind of maybe weakening things overall. But if I kind of ignore that outlier, I'm going to say, look at those points. They're pretty close to this trend line I've drawn in. So I'm going to say that my scatter plot is moderately strong. I'm not going to say very strong, but I'm definitely not going to say weak either. So moderately strong seems appropriate. All right, so now I can come back up and continue my sentence here. So the association between study time and test scores is, and now I have these adjectives. Why don't you take a crack at writing out the sentence? How would you sort of order the things you're supposed to mention? And then unpause to see what I came up with. So here's the sentence that I completed. It's nonlinear with one outlier at 455. Okay, it's really important that if you note there is an outlier or a couple, that you say where they are. Positive and moderately strong. So that's the sort of full sentence you'd want to throw down there. CFODs to maybe try to help you remember what are all the components that we're looking for. Let's move on to the backside. So on the backside here, let's talk about sort of some extremes here. So the very first one over here on the left, this scatter plot shows what we call no association between the two variables. Why is that? Well, that's because the scatter plot shows no noticeable form or direction. Any sort of trend line I try to draw in there that I think is going to work, if I handed this scatter plot over to a friend, they might draw an entirely different trend line. Like, I don't mean like a little bit different, like they might think, oh no, it's like negative slope, and I drew positive slope and things like that. So if you see something like this, it means that the two variables are not related in any sort of way, and thus maybe not worth our time to analyze at all. However, on the other end of things, there are scatter plots that we might confront that show a perfect positive linear association. You can see that those dots all fall on the same line. They have no outliers either. This is a perfect association between these two variables. Now, while I said we might see something like this, it would be only in examples that we sort of make up, because this is very rare in real life. I would say that all those sort of, quote unquote, real life data we'll be dealing with, whether it be from the College Board or actual real life data that I scrub up, that it will never follow a perfect model here. So your data will never, ever follow a model perfectly by just, grabbing some data from the real world, unless you kind of plan it out for the most part. So in math, we talk about the x variable and the y variable, and sometimes those are referred to as independent variables and dependent variables, but stats has different language for what goes on the x-axis and what goes on the y-axis. We don't want to use actually the terms independent and dependent, because actually those mean something very specific in the probability work we'll be doing throughout the year. So instead we use these phrases. We have an explanatory variable. So explanatory variable is thought to be sort of like the variable that kind of like explains or predicts sort of what's going on with your y values, which are called the response variable. So explanatory ends up being on the x. I'm not a fan of like memorizing weird stuff, but if you needed to, explanatory x-axis, there's a mnemonic device for you if you need it. And so the other one would be the response variable, and so this is the one that sort of gets explained by or predicted by the one that maybe, responds to the explanatory variable, the x variable. So this is the one you put along the y-axis. So to see if you sort of understand which is which, and I'm going to leave this one to you to try out on your own, which of the two variables listed here would you say is explanatory and response? So here, beach visitors and water temperature. So which one do you think explains the other? Or which one is responding to the other, whichever question you want to ask yourself? Same thing, weekly exercise and resting heart rate. Which one do you think kind of explains? So make sure you pause and put in those answers there. I'm moving along though. So here, let's continue. So as we were sort of noting on the front side, sometimes it can be a bit tough to sort of decide on strength. I started with 2 buckets. I said weak and strong. When I went to go describe mine, I said moderately strong. But then what's the difference between moderately strong and moderately weak? Is there such a thing as just being moderate? Is there a cutoff? Well, yeah. So there is sort of a way we can sort of think about how to cut these things off with numbers. So rather than going with gut feeling, we can calculate some numbers to help us do it. And the thing that would help us to start out with is this thing called R. So R has some cool things with it. Okay, so first off, R is called the correlation coefficient, and the sign for your correlation coefficient gives you the direction. So if you have a negative R value, you know that the relationship has negative direction. If you have a positive, then that means you have positive direction. And then the value of it, so the magnitude of it, so it's always going to be between -1 and 1, and the magnitude, how close you are to 1 and -1, tells you about the strength of the relationship as well. So here are some examples sort of down below. We have here perfectly negative, spanning all the way to perfectly positive. So what are the R values for these? These are just some examples that may not even be necessarily absolutely correct, but roughly these values. So if you're perfectly negative, your R value is -1. All right, but as it gets maybe a bit weaker, so it's not perfectly strong, it's still kind of strong, you start dipping down closer to maybe the -0.5. As you start to dip even lower than that, you're dealing with a weak association. Here we are, relatively close to 0. That middle one there, R is 0. So things that have no association have an R value of 0. And then you can see as we move to the right, we're starting to see things that are trending a little more positively. So here we'll say this is 0.3, so weak. As we get stronger, we'll call this 0.8. And this last one, perfect, so it is R equals 1. So you'll see lots of things. Your calculator will give you more decimal places in all of this. You might see more decimal places. It's not just always to 1 decimal place. But that's sort of an interesting sort of thing to think about the spectrum here and sort of what you'd expect. So on number 2 there, we're going to talk about kind of an interesting thing. This is a common MCQ, actually, that kind of pops up. They'll give you an R value for some association, and then they'll say, hey, what if we switched the X's and Y's around? What would the new R value be? Here's the thing. Your R value is unaffected by which one is the explanatory and which one is the response. So if you were to flip it, it would not change anything. Rescaling, transforming your data, doesn't change anything. So keep that in mind. An MCQ problem is definitely going to probably pop up for you at some point where that will be part of it, is saying like, oh, we're going to swap this, or tell me something you know about R, and it's going to be about how rescaling it does nothing or switching does nothing. The other thing to note about a correlation coefficient is that it only is helping us measure linear associations, okay? So a strong association could exist between 2 variables, and it might end up having a low R value because what you're seeing is something maybe not linear. And the flip is actually true. Sometimes you have an amazing R value, but it turns out the thing you're looking at isn't actually linearly related at all. So it's something to sort of keep in mind. Like here, when I look at this little scatter plot over here, I can see that there's a clear relationship. However, if I were to try to fit a line to it, do I do something like this? Or like, do I do something more like this? You can see that a linear function isn't going to go through it. So this one here, it's going to have a really low correlation because it's not a linear relationship. So keep that in mind, is that we really only want to use this for linear, which, as it turns out, will be something we'll always want to deal with and can figure out how to change curvier things to not curvy things, but that's for second semester. So to kind of finish this up, you might be wondering, well, where does this R even come from? How do you actually calculate R? Well, I'm going to tell you right now, you could sit down and calculate it. The way you calculate it is actually based off of z-scores. So check out this formula right here. These little things in the parentheses down here, those look awful lot like how you calculate a z-score. It's an observation minus the mean divided by the standard deviation. So as we read this formula, what you kind of do is you find the z-score for all of your x's and all of your y's, and you multiply those pairs together, You add up all those products and then divide by n minus 1, which, again, hopefully is starting to make sense because we now know that standard deviation for samples is dividing by n minus 1. But I'm going to say we're not going to do that, which is weird because let's flip to the formula sheet real quick. We can see that one of the formulas given on here is our correlation coefficient. They give us the formula on the formula sheet. So it kind of seems like, oh, you're going to have to use it and calculate it at some point. And that's wrong. This will be the only time we really stare at it. It's just, I guess, nice to know. And, perhaps a good reminder of like, well, conceptually what's happening with an R value. Oh, it's finding these Z-scores and kind of finding out how they pair together. And if you're really interested in digging in more to it, feel free to come in for flex. But the long story short here is do not calculate R by hand, okay? Yeah, you should understand what that formula sort of is saying, but it's not about using it. Let the calculator do all the heavy lifting for you here. So how do you find R? Well, there's a little function in our calculator known as linreg, parentheses, A plus bx. And it will help us find that R quickly. So let us go to our calculator to see how to do that. Let's go ahead and see how we can find our correlation coefficient. So first, double check that your lists are appropriate. I can see they're the same length, and those are the numbers. So to find it, what we're going to do is we're going to hit Stat, and then arrow over to Calc. And we're going to use option 8 here, linreg A plus bx. You might notice that number 4 is very similar, except for that form of the equation for a line, while valid, is not the one that we use in statistics typically. We tend to use it this version here. So all of our work will always be looking like this. So that's why we stick with this instead of kind of bouncing back and forth. It gets a little confusing if you're talking about A and B. They mean different things here. So our course will always use number 8 there. So I'm going to hit 8. And you can type in your lists. If you have an older version of a calculator, right now it just said like linreg, and then behind it you're going to type in L1, comma, L2 and hit enter. Or you can actually add in another thing, which we can do as well, which is you can store your regression equation. To do that, so what it'll do is it'll store it in the y equals menu for you automatically. So when it generates the equation, it'll also stay there, which might be helpful in the future. To actually store it, what you would do is you would hit the vars button, standing for variables, and we would arrow over to yvars and click function, number 1 there. And you can store it in any of these I always just choose y1 right there. And so now when it comes up with the equation of the line, it actually will then store it there as well, which will be helpful, again, in the future. Right now, we don't really care that much. And then I'll go ahead and hit calculate. And there's the equation of our linear regression line, which our next video will go into more thoroughly. And you might be going, wait a minute, Mr. Schulten, you said we would find R. I don't see R anywhere on here. Now, maybe your calculator is showing you R, and if that's the case, awesome. You can just say great and then stop the video if you want, or fast forward the video, I should say, if you want. If you're like me, where it's like, wait a minute, you said this would show R, I don't see R anywhere on here, you have to turn on something called diagnostics for it to show up. So let me show you how to do that. So to turn on diagnostics, what we're going to do is go to the catalog. To get to the catalog, we're going to hit the second button, and then we're going to come all the way down here to the number 0. You can see in blue it says catalog. So this takes you to literally all the different functions in your calculator alphabetically. We want diagnostics, D. Do not start arrowing down. You can see the alpha lock is on right now because you can type in the green letters around here and fast forward to the letter you want. We want D, which is right here on this x to the -1 button. And so that takes me immediately to all the D's. Let's arrow down. And we see here, diagnostic off or on. We want it on. So Make sure your arrow's next to that and hit enter. It'll take you back to the home screen, and you're going to want to hit enter again. Once you do this, you should be good. The only reason why the diagnostic would turn off again is if your calculator does a hard reset, which might happen sometimes. So if you ever find yourself needing it on and you aren't quite sure, you can ask or revisit this video. So now let's go ahead and go back to our linear regression. We're going to hit Stat, Calc, number 8. My lists are all still there. I'm going to skip the equation thing right now. It's still stored from before, but I don't really want to worry about it right now. And hit Calculate. And there you have it. So now we have those A's and B values that we were talking about earlier. And then R squared and R. R squared will be in the next video, what that means. But here's our correlation coefficient, 0.7522-ish. So that brings us to the end of our video here, introducing some associations and scatter plots. So please make sure that you have thought about these explanatory and response variables before you enter class, and we will see you then.